So how is this problem coming along?
I'm not really sure, but I'm trying it on paper.
Sounds good.
Okay, I got my answer.
All right, did it confirm?
Yeah, I did.
Excellent. Which identities did you use?
Is it the Pythagorean?
Sounds good. All right. So I think we should try maybe the problem starting at 53. So the ones where we're given not an angle, but given the answer. So for example, how do we find the angle that when we take the sine of it gives us an answer of 1/2?
We know that sine is oh, we take the negative.
We could do that.
Negative the inverse.
Yeah, we could do that. But another way we could do it would be taking into consideration the fact that sine is y over r, so y is 1, and the hypotenuse of our right triangle is going to be 2. So y is positive, which means we're in quadrant 1 or in quadrant 2. We're not too sure. We want to consider both scenarios. All students take calculus tells us that it could be either of these two. So we could actually have two answers. Y is 1, and then our radius is 2. So this one doesn't really apply to the unit circle that much because we have a hypotenuse that's 2. So r is 2, y is 1. And by the Pythagorean theorem, that means that the base has to be 3. So that's one consideration. And then another consideration would be this right here. The same exact thing, but with an x value of negative square root of 3. So we can tell that we have a 30, 60, 90 triangle. The 30 is the angle that forms with the x-axis in both cases. And we have a 60. So a 30-degree angle is pi over 6. So our choices for this one, our answers are pi over 6 And then this one would be 1/2 circle minus pi over 6. So the other one we have is pi minus pi over 6, or just 5 pi over 6. So these are the two answers for this one. And you would get the same thing. I think the calculator will only give you pi over 6. Do you want to try that real quick? Try the calculator method and see what you get.
Okay. I got 30 degrees. Yeah.
Yeah. They don't show us the other one. They only show us the reference angle version. So in this case, pi over 6 or 30 degrees would be the reference angle. And then the other one we have in quadrant 2 would just be an additional one. The calculator only gives us the reference angle. So let's try part B. I'll let you decide if you want to use the calculator or if you'd rather draw it out. See if you can find the angle that when we take the cosecant of it, gives us a value of 2. Here, I'll write it.
So try both ways.
I want you to decide which way you'd rather do it, and then see what you get.
Is this supposed to be 30?
Yep.
30 degrees?
Same exact thing as the last time. So another way we could approach this is take the reciprocal of both sides.
Yeah, that's what I did.
Yep, and then it just turns into the same problem we had last time. So I think they're all going to be like that. I think for problems 53 through 58, the A and B are going to yield identical answers. So let's have you try maybe 56. Tangent of theta equals square root of 3. So what would be the most effective method for this problem? Well, let's see if we can do it first without a calculator, and then at the end we'll use a calculator to check our answer.
Okay. Wait, how do I find it again?
So tangent is supposed to have a fraction as its answer. In fact, all of them are supposed to have.
Yeah.
A tangent is y over x. We have just a number, but we actually have an invisible denominator as well. So in this case, we have y would be square root of 3, and x would actually be 1. So our job is to find the triangle that has these measures, that has the y and the x specified as we have them here. But they're both positive, which means that we have to be in quadrant 1. So what angle would have these measures in the right triangle in quadrant 1?
I'm not that sure.
So let's draw it out. We want to draw the plane. And then our x value is 1. Our y value is square root of 3. And this is a special right triangle. The hypotenuse in this one has to be 2. So we know it's not 45, 45, 90. It has to be 30, 60, 90. We can tell that because the height is bigger than the base, square root of 3 is greater than 1. This has to have a 60-degree angle right here, or we could call it pi over 3. So we have pi over 3 as our angle then. So theta is pi over 3 in this case. You could also get the answer using the calculator. You could just do the tangent inverse of -3, and they would give you 60 if you're in degree mode.
Okay.
Let's try the next one. Cosecant of theta is 2 root 3 over 3. So are there any strategies that could help us with this one? Does anything come to mind?
I think I'm more comfortable with the calculator, so we could flip the.
But before we do that, we can use the calculator to check our answer at the end. I think we should take the reciprocal of both sides. So we get sine theta is 3 over 2 root 3, and then we rationalize the denominator. So we get 3 root 3 over 6, so that is root 3 over 2. So the sine ratio is y over r, so y is square root of 2, y square root of 3, and r is 2. So the fact that our radius is 2 means this is a 30, 60, 90 triangle. The only thing we really have to do now is identify if theta is going to be the 30 or if it's going to be the 60. And both are, and the y is positive, which means that our angle has to be in quadrant 1. So y is square root of 3. It's the same angle we had last time. Y is square root of 3, r is 2. So angle for this one is pi over 3. I think the calculator would also give us 2 pi over 3, but the calculator would only give us 1, but 2 pi over 3 would actually work as well. Even though the calculator only gives us one of those angles, we have actually 2 that work. Let's do maybe just one more of these, and then we'll move on to something else. So I'd like for you to try number 54. We have cosine of theta equals square root of 2 over 2. See if you can find it without a calculator, and then use the calculator to check your work.
So 45 degrees?
I think so. (45 degrees) is pi over 4. So cosine of this would be adjacent over hypotenuse. Yep, exactly right. 45 degrees is correct. So let's try a different kind of problem. Let's say we have a 30, 60, 90 triangle. And we have a base of x and a height of 30. How do we find x?
You can do tangent. Tangent 60 equals x over 30.
Yep. Would it also work to do tangent of 30?
Yes.
All right, so see what you get for x.
I got x is equal to around 52.
I got 30 root 3, and that could be the same thing you have. So square root of 3 times 30. Oh, hang on.
Yeah, that's what I got.
Awesome. Very good. Let's try another one of these. So we have a 60-degree angle. We have a hypotenuse of 18, and our height, call it y. See if you can find y.
15.6, so 16 around.
I got 9 times square root of 3. Yep, I got the same thing you got. So another way we could do it is we could compare it with a reference triangle, which is the way I've just been doing these in my head just by comparing this with a reference triangle for 60 degrees. So it's a special right triangle. We know from geometry that this particular triangle has side lengths of 1 and 2 and square root of 3. So the question is, what number do we have to multiply our hypotenuse of the small triangle by to get the bigger one? And the answer is 9. So that means all we're doing is we're taking the small triangle, we're scaling all 3 of our sides up by 9. So that's how I quickly got y is 9 square root of 3. We can also do the same thing with the next one. Let's try number 61 using this method. So we have another 60-degree angle. We have a height of 32, and we want to find the base, call it x. So an ordinary 30, 60, 90 triangle is 1, 2, square root of 3. So we're trying to figure out what number we have to multiply square root of 3 by to get to 32. So that would be times 32 over square root of 3. So we have to multiply every side by k. So we have square root of 3 times k equals the same side on a similar triangle. So k would be 32 over square root of 3. And then all we really need to do is multiply 1 by the same thing. So x would just be 1 times 32 over square root of 3. And then we can do the same thing in 62. We have a 45, 45, 90. So we're trying to find the hypotenuse, r, and we know that the height is 20. So in the reference triangle, we know that we have 1, 1, and then square root of 2. So really all we have to do is multiply every side by 20. So that means r has to be 20 root 2. All right, so I thought we would spend the next 10 minutes or so reviewing reference triangles. And they come up a little later. They come up on page 314. And let's just refresh ourselves on what reference triangles really are, or reference angles. So reference angles are angles that have the same trig functions. So for example, what if we had an angle of 30 degrees? And what if we add another whole circle to it? So we get 390 for our second one. 30 or 390. So notice how the triangle is the same for 30 as it is for 390. If we take the sine of 30, we get the same answer as we would for the sine of 390. And that's all reference triangles are. They are triangles we use to find the trig functions of really big angles. So a reference triangle should always be acute. It should always be an acute angle. And they have the technical definition: let theta be an angle in standard position. Its reference angle is the acute angle theta prime formed by the terminal side of theta and the horizontal axis. So we have a few examples here. So let's see if we can find the reference angle for a 300-degree angle. The reference angle, theta prime, would be, so our goal is to find this angle. We want to keep subtracting multiples of 90 until we're in quadrant 1. So 300, we know we're in quadrant 3. So let's subtract 180 from that. We get 120. And 120 is in quadrant 2. So let's subtract 90 from that. We get 30, which means the reference angle for 300 degrees is 30 degrees. That means that the sine of 300 degrees is the same thing as the sine of 30. And same thing for the other 5 trig functions as well. All right, let's try part B. Theta equals 2.3 radians. I'd probably put this in degrees first. So we can write this as, I'm hearing a bit of an echo. Do you hear the echo too?
No.
Oh, I think I'm not hearing it anymore. That was just for a moment. So I don't like having decimals in my fractions, so I'm thinking I might multiply the top and the bottom both by 10. So instead of 2.3, I would have 23. 23 pi over 1800. And then we can just keep subtracting multiples of pi until we get the thing we know we should be having. Or actually, hang on a second. Oh, wait, this is already in radians. So we want to actually multiply it by 180 over pi. 180 times 2.3 is 414 degrees. And then pi is approximately 3. Let's round that down to 3. 414 divided by 3 is 138. So we have 138 degrees, and then we know that that's in quadrant 2, so we want to subtract 90 from that. 138 minus 90 is 48. So theta prime, in this case, would be a 48-degree angle. Let's try the same thing with an angle of negative 135 degrees. So a thing about reference angles is they can't be negative. If we have a negative angle, we want to keep adding multiples of 90 until we get into the positive. So 135 is pretty close to 180. I want to start by just adding 180 to this. So once we do that, we have a 45-degree angle. So that's our reference angle. If theta is negative 135, then that means theta prime is positive 45. All right, so let's skip down a little bit. Let's skip down to 316, page 316, which applies to using reference angles to help us solve, or to help us find values of trig functions. So we're at page 316, and we want to find the value of cosine of 4 pi over 3. So we want to find the reference angle of this. The reference angle of 4 pi over 3, well, let's draw it first. So we know 3 pi over 3 is a semicircle. That's just pi, it's just halfway around the unit circle. So that means we're going to go halfway around, and then we're going to add 1 more pi over 3, which takes us right here in quadrant 3. So we can see that this is a multiple of pi over 3, which means that we have a 30, 60, 90 triangle with side lengths of 1, square root of 3, and 2. Except because we're in quadrant 3, all students take calculus. It tells us that we have a -1 for x, negative square root of 3 for y, and then r is just going to be 2. So let's find the cosine of this angle. Cosine is going to be, oh, and I forgot to mention that whenever we take the reference, whenever we use this to find the cosine of our current angle, we make everything positive because we know we're in quadrant 1 when we find the reference angle. So we want to subtract maybe 180 from this. So we're in quadrant 3. Subtracting 180 would take us back to quadrant 1.
Wait, so why do we have to do that again?
Because sometimes it makes it easier to find the trig function value of this. So this is the same thing as having cosine of pi over 3.
Oh, okay.
Cosine of pi over 3 is square root of 3 over 2, which means cosine of 4 pi over 3 is also going to be square root of 3 over 2. So that's why they're really useful. Reference angles just help us find values of the trig functions a lot easier. All right, well, that's all we have for today. Let's see if there's anything we can do to give you a little bit more practice. For homework, let's have you do the vocabulary check on page 318 and then a few more problems after that. So that's it for today. And as always, if you have questions about any of them, just circle them or make a note, and then we'll go over those tomorrow.
Okay, thank you.
No problem. See you tomorrow.
See you tomorrow.